and is this derivative. So now that we know how to take a couple of derivatives, we're going to start applying this to tangent and normal lines. So a tangent line, we already learned that a derivative gives us the slope of a tangent line at any point along a curve. So to find the slope for the tangent line, we're going to take the derivative. And then a normal line is just a line that's perpendicular to the tangent. So if we know how to find the slope of a tangent line, we can just use opposite reciprocal slopes to find the equation of a normal line. Okay, so let's just do some examples to see all of this in action. So we have find the gradient function, which now whenever we see slope and we don't have something that's linear, this is going to be an indication that this is a derivative. So this is saying find the derivative for this function and then find the derivative at x equals 4. So we're going to plug that in. So let's first just start by finding the derivative. So we have f of x equals x squared minus, I'm going to change this to x to the 1/2 and then bring it up. So this is 4x to the negative 1/2, as we've done in previous videos. And then let's go ahead and take the derivative. So this would be 2x, and then 1/2 times 4 would be just 2x to the negative 3/2, making that look a little more proper. This would be 2 over the square root of x to the 3rd. Okay, so we did the first part. We found the gradient function or the derivative. And now it says we want to find the gradient of the tangent at x equals 4. So to find that, we're just plugging in 4 to our derivative. So we're going to do f prime of 4 is 2 times 4 plus 2 over the square root of 4 cubed. And let's go ahead and simplify. So that would be 8 plus 2 over the square root of 4 is 2, and 2 cubed is 8, which is really just 1/4. And you are going to have to do some fraction addition, so make sure you're good on that. So we're just going to multiply by 4. So f prime of 4 would equal 32 plus 1, so 33 over 4. Oops. Okay. All right, let's do the next one. So for this one, find the coordinates of the point on the graph where the gradient is 4. So whatever this function is, we're trying to find where do we have gradients of tangent lines that equal 4. So again, when we see gradient, we're going to be taking the derivative. So let's find the derivative. So we have f prime of x equals 3 times a third would just be 1. So we have 1x to the 2nd. 2 times 1/2, again 1, so minus 1x minus 8. And remember that constants are 0, so this would be our derivative. But this one is asking us to figure out where the gradient, or when the derivative is, which is equals 4. So now that I have the derivative, I'm going to set the derivative equal to 4. So we have 4 equals x squared minus x minus 8. And then by now we should be really good at solving these. So I'm going to move the 4 over, x squared minus x minus 12, and we can go ahead and factor to solve. So x minus 4, x plus 3, and we get x is equal to positive 4 and negative 3. So at positive 4 and at negative 3, the tangent line had a slope of 4. They did ask us for the coordinates of these points, so we would need to find the y values of these points, and we would get that by plugging it back into the original equation. So if we do a different color, f of 4, you know how to do all this. So 4 squared minus 8 times 4 plus 7. You can just use your calculator to plug all that in. And that comes out to negative 35 over 3. If we do the same thing with negative 3, we plug it all in, then it comes out to 35 over 2. So our coordinates would be 4 comma negative 35 over 3 and negative 3 comma 35 over 2. So always make sure you follow what they're asking for. All right. Next one. We've got, this is our function f of x. We want to first find the derivative at x equals 1, so let's do that. So A, we have find the derivative. As always, you should be trying these on your own before you see what I'm doing, but whatever works. So we're going to take the derivative. So this would be 6x, the constant 0, so it's just 6x. And it wants us to find the derivative at x equals 1, so we're plugging in 1. So 6 times 1 is just 6. So if we're just visualizing this, we have this parabola, looks something like this. And they're saying when x equals 1, the slope of the tangent line here is 6, okay? So now for part B, if I want to find the equation of the tangent line, just like we've always done for any other linear equation, we need a slope and a point. So we already know that the slope is 6. We already know that we have it going through this point at x equals 1. We just need to find the y value that corresponds with that point, and we can do that by plugging it into the original function because it's on the parabola. So f of 1, 3 times 1 squared minus 2. So 3 minus 2 is just 1. So we have a point. We have the slope from the derivative and we have the point from the original function. And now we can use those to find the equation of the line. You can use whatever form you want. I'm going to use point slope because I have a point and a slope. So this would be y minus 1 equals mx minus 1. Okay. If you did slope-intercept form, we could rearrange this. So this would be 6x minus 6, or y equals 6x minus 5. However you want to solve for the equation of line, you can do it whatever way you like best. Okay. For part C, running out of space a little bit, but part C, they want us to find the equation of the normal. So as I was saying earlier, the normal line is perpendicular to the tangent line. So if we know that the tangent line had a slope of 6, then the normal line is going to have a slope of negative 1/6, and it's still passing through that point 1, 1. So I have a slope, I have a point, and then again, we're going to find the equation of this line then. So whichever form you want, I'm going to use this one again. 1/6 x minus 1. And then you could leave it there or you could put it in slope-intercept. Okay? All right. Last one. So this one, find the equation of the horizontal tangents to the curve, all of this. Okay, so just visually again, this curve looks, this is not even a good sketch, but something like this, okay? If we are talking about horizontal tangents, a horizontal line is when it would be like right here or right here. And what is the slope of a horizontal line? The slope would be 0. So what this is really asking us is, when is the derivative equal to 0? Because we're trying to find when the slope is 0. Okay, so let's find the derivative. We have dy over dx, I'll use this time, equals 3 times 2 is 6, so 6x squared. 2 times 3 plus 6x minus 12. We wanted to find when is this derivative equal to 0, so I'm going to do 6x squared plus 6x minus 12, set that equal to 0. We can take out a 6 here, so x squared plus x minus 2, and then factor. So we get x minus 1, x plus 2 equals 0. And then we get x is 1 and negative 2. So at the values of 1 and negative 2, we would have those horizontal tangents. All right. In this video, we did a lot of problems, but we did learn how to find the slope at a given value of x, and we did that by finding the derivative and just plugging in the value. We learned how to find the equation of a tangent line by using the derivative to find the slope and then using a point on the original function. And then we learned how to find the equation of a normal line by using the perpendicular slope and a point on the function. Thanks for watching.